Okay, let's go down to this second section here, asking us to do the same thing except for the instructions are just a little bit different. It says we're going to factor by grouping, but it's also telling us not to forget to factor out the greatest common factor first. That should always be your first question whenever you are factoring. Whether you have 4 terms, whether you have 3 terms, or 2 terms, your very first question should be, can I take something out of all of these terms? So we're going to look at number 5. And number 5, I have 4 terms here. And before I begin grouping, I need to ask myself, is there something I can take out of all 4 terms? And the answer is yes. I can take out an 11 from all those numbers, and I can also take out an x squared for all those variables. So that's what I'm going to do first. Before I start grouping or anything, you must always take out that greatest common factor first. So here I can take out a positive 11 x squared. Actually, I'll move that over a little bit. Taking out a positive 11x squared, which would give me 9xy minus 3x plus 3y minus, now, if you take out the 11 and you take out the x squared, okay, there's nothing left. I'm going to put nothing in quotes. There is always a placeholder. It can never be 0. It's always a 1. Because if I were to distribute this back out, take the 11x squared times the 9xy, I'm going to get the 99x to the third y. 11x squared times the negative 3x, I'm going to get a negative 33x to the third. 11x squared times the 3y, I'm going to get a 33x squared y. If I take that 11x to the squared times a negative 1, that's going to give me that negative 11x squared. I can't get rid of it. Okay, perfect. We've taken out the greatest common factor. Each one of these terms no longer has anything in common. So I'm going to go ahead and group them. That's what factoring by grouping tells me to do. I need to group these so that they have common factors. I need to make sure terms are next to each other in which I can take something out of. It's already set up fairly nicely here. I'm going to leave them in these groups. I'm going to group that first and group that second. In this first set, I can take out a 3x. It has a 3x in common. I'm going to go ahead and do that. If I take out a 3x, I'm going to be left with a 3y. Once again, minus a 1. I can't make that a 0 because I have to be able to distribute back out and get my original expression. If I look at this second example, the only thing I can take out of here is a 1. Remember we talked about earlier, we want whatever is in parentheses to match. In this situation, this set of parentheses already matches this set of parentheses. So if I take out a positive 1, it's not going to change the value. If I take out a positive 1, that's where the plus comes from because a positive is being taken out. I am still left with a 3y minus 1. Because once again, I can distribute this 1 to both terms. 1 times a 3y is going to give me that 3y. 1 times a negative 1 is going to give me the negative 1. So I know I've done it correctly. Now what I should notice is whatever I have in parentheses here is the same. And since it's the same, I know I can factor something out. It should always be the same. It should never be anything different. I'm going to go ahead and take out that 3y minus 1. When I do that, in this first term, I'm left with a 3x. Take out that 3y minus 1, and I'm left with a plus 1. Now my rules are not changing. Whenever I'm factoring, it tells me whatever is on the outside here is going to stay on the outside. Whatever's left over goes in parentheses. That hasn't changed. Now, I'm going to pose a question to you and think about it for a second. Am I done? Is my problem complete? There is something very small, yet very big wrong with this. Can you see it? This is the mistake we made a lot on our quiz. We took out an 11x squared when we first started this problem. I cannot leave it over there. That 11x squared has to come to be a part of my answer. So what I get as my final answer is an 11x squared times a 3y minus 1 times a 3x plus 1. Now I'm done.